Okay, I think people are trickling in. We can get started. We won't keep you waiting any longer. Welcome. My name is Geetika Pandya. I'm a senior research associate at 3IE, which is the International Initiative for Impact Evaluation. Um, Today, we're going to be presenting on AI for impact evaluations, practical applications, and lessons learned. These will be a bunch of use cases of AI that we've applied in recent evaluations in our work. And this presentation is the work undertaken by the Data Innovations Group at 3IE, which comprises of Fiona, Kastel, Devika, Lakhote, myself. All of us are on the call, as well as our colleagues Sanchi, Lokhande, and Carlos Falcon, who couldn't join us today. Thank you for being here, and let's begin. Okay, so uh, I'm sure that in our audience today, there are several people using AI. Actually, I can make a safe guess and say everybody's using AI, but maybe for different use cases. So it's possible that your team is just using AI to review an email or simplify language, um, point out the logical inconsistencies in a report, or you're using it for more advanced applications like data cleaning, interpretation, or analysis. Whatever your use case might be, it's hard to deny that AI is a part of our toolkit in the current day and age. With that becoming true even in the development economic space, wherein AI has applications in the labor markets, in education, in public services, for us as evaluators, that raises a very pertinent question. How is it that we can integrate AI to enhance the quality and policy relevance of the evidence that we produce, and not just simply speed up workflows? This is a question that we've been grappling with at 3IE's Data Innovations Group, and the applications that we present today will showcase the challenges as well as the achievements that we've had through those applications. We're going to be walking through 4 applications today. In each of these, there's one through line, but through all of these applications, we've been able to uncover certain capabilities that weren't possible before. So for example, we've been able to expand the realm of the types of sources of data that we could work with. We've been able to strengthen our evaluation design using AI. We've been able to analyze larger volumes of data than ever before. And we've been able to do all of this faster and more cost effectively than was thought possible. So ultimately, our aim with using AI is to be able to dream up more ambitious evaluations and research applications that will help us bring us closer to the challenges that we had once thought were insurmountable. I'm going to walk us through the first application that we undertook. In this case, we used AI for image classification. It helped us in two ways. One is that it helped validate our intervention design. And second, it helped us construct additional outcome measures. Let's see how it helped us do that. Okay, so for an aquaculture evaluation that our team was tasked with, we needed to get reliable details on fish pond presence and characteristics in fields. We had access to satellite imagery and we had field level photographs, but these were in the thousands. So for our team to be able to sit down and manually review and classify each of these photographs would have taken a long time and would have also probably resulted in inconsistent findings. We needed to verify whether ponds actually existed, whether they held water, whether they were formally constructed, and were they in use at all. So instead, we used AI. We wrote code that calls the OpenAI API to classify ground level field photos of fish ponds across some structured dimensions. These dimensions were water visibility, water size, the color of the water in the pond, the structure of the pond, as well as the surrounding land. So what happened is AI helped us validate the survey data that we had collected and helped us construct new covariates and outcome measures on aquaculture practices. It helped us develop a new kind of human verification system, which we used for AI-generated outputs. And the applications that of this human verification system goes beyond just this aquaculture intervention. It can be applied to several geospatial and satellite image classification applications that we undertake in the future. Just to give you a sense of how this workflow, we went about this workflow. In step one, you'll see we have raw inputs, which could be, in a different case, could be documents, it could be transcripts. In our case, it was images. In the second step, they went through pre-processing. Using optical character recognition, the model classifies images into text and then is fed into an AI model, which extracts, classifies, and summarizes the data that it's seeing. It then gives us a structured output in step 4, which is in the form of tables, variables with labels. And then in step 5, it undergoes a human review. If we check for accuracy, we check for edge cases and outliers. We make sense of the data essentially. In step 6, after our human review, we go back and refine certain prompts or definitions based on the results we're seeing. And it goes back into the AI model and does step 3 to 6 all over again. And if after the human review, we find that everything is in order, we create the final validated data set, which is quality checked and ready to be exported. So this is an example of an AI-assisted data workflow that kind of applies across the applications that we'll be speaking about next. I'm going to hand over to my colleague Devika to walk us through the rest of the applications.
Thanks, Geetika. One thing I wanted to mention about this specific use case before I go to the second one was that often when we collect data on the ground, we do take these photographs, and it's important, and we'll talk about this in our word of caution segment as well, but to make sure that you're using a secure API to process these images and things like that, but also to remember that we were always taking these photos of different survey sites, and we were not able to make as much use of them before as we are now able to. So this almost becomes like an additional layer of analysis that we can do that we weren't thinking of doing before with photographic evidence from the field. So it's really a case of we already have this data often from the baseline surveys and line surveys, and we are not using it to its fullest potential. And AI is enabling us to do that, which is pretty cool. Okay, second use case is a similar situation where we have information and data already existing, but now we're able to leverage it more fully. We're using AI to create outcome variables, generate structured outcomes from full text proposals and publications at scale. So our challenge in this case was that we were tasked with studying if research grants improved the creation and quality of evidence, which required comparing hundreds of funded and unfunded proposals to each other to see whether getting funding from a specific source improved the creation and quality of evidence because of certain requirements of those RFPs and so on, to see what is the value of funding these proposals. And in order to do that, you had to compare those funded proposals to comparable proposals that didn't get funded. And we had a nice evaluation design, a quasi-experimental setup. However, we wanted to measure richer dimensions for outcomes rather than just, say, citation counts to measure, say, quality of evidence. And in order to do that, we wanted to measure outcomes such as whether the study used mixed methods, whether they were transparent about their methodologies and their general analysis practices. Did they have stakeholder engagement? And these kinds of outcomes that are more qualitative in nature, not exactly immediately discernible from the abstract or the title or things like that would require you to read the entire proposal to understand what the proposed methods were and what were the proposed sort of transparency commitments and so on. And this would have been beyond the scope of a typical impact evaluation, mostly because of a lot of funding constraints, time constraints, and often, like Geetika mentioned, even in the first use case, difficult to have humans review, tons and tons of papers and have consistent outputs from each one of them on these categories that can be a little bit, I would say, fluid or opaque. And so we used AI to help us with this specific task. We generated a script that called the OpenAI API. Specifically, we used GPT-5 in this case, which was important because at that time, GPT-5 was able to do this task really well, but not certain other models. So that's also a dimension to think about when you're thinking of using AI for your different use cases. We extracted these variables from hundreds of documents with 90 to 100% accuracy. And the way we validated this accuracy was we compared the OpenAI outputs or responses to human annotation, and depending on the complexity of the outcome, we were able to see variation between 90 to 100%, which we thought was very promising. And one more thing to think about in this case is one of the benefits of AI, and as you're thinking about, okay, when does it make sense to use it versus when does it make sense to not use it? Unstructured text and unstructured documents is a really really good use case for these models, especially because it's able to read large volumes of text and make sense of them and extract information from them. And one thing you can always do is ask it to give you a snippet of where did it find this information, and then you can always double check, okay, where this extracted snippet came from this section of the document. So we were very happy with the fact that we were able to do this. Okay, a third use case. In this case, we were using AI at an earlier stage of the evaluation, right at the step where we were trying to come up with an evaluation design, specifically a mixed methods design that included a quasi-experimental component as well as a qualitative contribution analysis component. And we were rapidly trying to synthesize large volumes of data to be able to come up with this design. The program itself, our challenge was that we wanted to formulate an evaluation design for a complex, decade-long intervention on a compressed timeline. And we were drawing on a large corpus of reports, administrative databases, policy documents, and institutional records. And again, to mention, this was a decade of documentation. So there were over 600 plus documents that were unstructured, again, lots of text in German, Spanish, English, that we then used AI to read and translate and extract key information from. In this case, we used GPT Nano because our task was not as hyper-specific as the second use case, so we were able to use a slightly lightweight model and still get the information that we wanted into a structured database, and then we were still able to use that for human review. Then we also transcribed and translated stakeholder interactions from Spanish to English using a secure qualitative data analysis tool called ALIs to generate summaries. And we had about 20 interactions, not just one-on-one, but also in group settings where multiple people were talking, and there were a lot of different points of view and voices. So being able to take all of that information and convert that into diagrams, convert that into text that we could then review to come up with our evaluation design was extremely valuable and helpful. And then the last use case is for handwritten non-English records, where we process large volumes of multilingual handwritten records into structured time series data that would otherwise not exist. And this one is still in a pilot mode, I would say, and we are developing some ideas to test this, but we thought we would share with you one of our use cases that are in development, and probably one of the harder ones that we're attempting. In this case, our challenge was that we have hundreds of thousands of semi-structured school records, and they're only available in handwritten non-English form. So digitizing them by hand would take months and significant funding. And so traditionally, this data would just not be collected, especially at the scale that we're trying to do it at, which is 100,000 plus pages. So how we plan to use AI to make this task feasible is we're developing protocols and piloting the use of LLMs paired with either OCR or some other type of scanning technology to interpret handwritten text at scale, recognize the context of the document, and then convert these images into outputs that will eventually become covariates, outcome variables, all of those things for our evaluation. And then the intended result would be basically a high frequency student level panel across 2 decades, which is a monumental task to undertake. And it's really incredible that we're able to feasibly do this because of AI in a timeline and funding that's feasible. I will hand it over to Fiona for this section, and if her Wi-Fi goes off, then she will hand it back to me.
I was just going to say the case study that Devika was just talking about, I'm currently in the field trying to validate the protocol for that. So if I cut out, just interrupt me, and Devika can take over. So for all of these cases, obviously there's a lot of promise, and we're really excited about the ways that we can use AI for our usual research tasks. However, we have some words of caution and some areas that are still uncertain in the use of some of these tools. So yeah, I'm going to walk through a couple of these. The first is that LLMs are not deterministic, which means that even if we put in strict settings to the model, the outputs by nature can still vary across each run. So if you input the same exact prompt, you're going to get a slightly different response, and that's kind of the basis or the benefit of a lot of these models. However, that means that there are chances that there will be mistakes in the output because of just the creative function or the differences in those outputs. So this is somewhat in some ways similar to having two different humans reviewing or extracting outputs, as we mentioned in some of the earlier examples with the extraction of certain characteristics from papers. Someone might interpret the existence of a theory of change differently from someone else. And of course, the instructions you give to that person matter the same way it would for an LLM. In addition, we usually do some review of, we either have more than one person extracting the outputs and then compare those, or in this case, we have the AI extracting the output and then we can have a human review that output or do the same task, at least for some portion of it, to get a sense of what the measurement error is or the inter-rater reliability in that case. And so again, one of the things we just emphasize here is because LLMs are not deterministic and outputs can change across runs, we definitely emphasize doing some sort of validation, and we can adjust for a lot of the errors that occur using our workflow. So the second thing to note is this is basically what I was just saying, but that oversight matters a lot, and it actually matters more, not less than it used to, just because of the fact that a lot of the AI output tends to be very convincing, and at a glance, it will always look reasonable or correct. However, the deeper you dive and the more critically you think about the output, you start to notice some errors. So we generally recommend what we've been doing for at least the cases that we presented is for most of the ones we presented, it was a lot of large scale data, or for instance, with the image classification task, we had thousands of images. And so we're not going to repeat the task again with a human. However, we would review at least 10 to 15% of the images every single line of the output and make sure that it is accurate, or we'd have a human do the same. Usually it's we'd have a human do the same task, not looking at the AI output, and provide their review of the image, and then we'd compare the two and get a sense of how accurate is this. And then, as Geetika had mentioned with the workflow, we might repeat the process of feeding the prompt into the AI model until we get to a level of the 10 to 15% of the random data that we have reviewed is at a high enough level of accuracy that we feel comfortable using it for the rest of the output. In addition, it'll like flag fields. Sorry, you can go back. A lot of the times we'll have, as Devika had mentioned, have the AI include a snippet of text or something where we can see a case where we don't understand why the output is happening, and it can help us refine the language as well. And then for certain outputs, and at least internally at 3AE, we usually recommend having 100% review of any written outputs the same way you would if you're writing a paper, you're going to review your output before you submit it. So we're just generally following the same principles you would, but being extra cautious of the fact that since you didn't write it yourself, there may be mistakes and it may look accurate. So you need to be very careful in that review. So the third point, yeah, the output is only as good as the data. This actually speaks a little bit to during the stages where we're doing the review of 10 to 15% of the output of a large scale data extraction. We sometimes the output might look incorrect when we're reviewing it as a human, but then you read the AI's rationale or the snippet that we had it extract, and you can see that, oh, actually, it was the data itself which had either an error or the output makes sense, but because of some like issue you hadn't really thought of. So for instance, for the image classification task, if a pond color was noted as black, which didn't really make sense, we expected ponds to be green or blue or brown. That wasn't an error. It was just an image taken on the ground that was at night. And so it was actually able to still see the pond, even though it was really hard to see in the image, but you can kind of barely see the outline of it, and it still was a pond, but it just wasn't visible at night. Yeah, and then I think this might be the last one, but we'll see. So the fourth thing is, especially with PII, we want to just follow the same best practices that we usually have. So for instance, with the images, and then with I think with the other examples, there wasn't necessarily PII involved. However, with the images task, and then also with the handwritten text, which will potentially include PII, we recommend either de-identifying the data. So in order to, if you're using AI to help you write code or something, first try to write the code without the real data, and then you can implement the code with the actual real data if needed. But usually we de-identify data anyway, and so that's why I'm saying continue to follow the same best practices we usually would with PII. And then using either a secure API or a paid, there are certain accounts that you can get with some of these models, which have stricter privacy settings. And this is something that is still, I think, is constantly changing. And so we have to be aware of what are the latest settings with these models. A lot of the times, one thing we just like to highlight is if you're using a free version of one of the common LLMs like GPT or Claude, even if you turn off the setting to train on your data, it might turn back on later on and you didn't realize it. And so just being really careful when you're interacting with these models, especially with PII, but also with other data if you don't want it to be used by those companies. And there's other platforms we've listed here that we have used because they have those extra security constraints like ALIs, and then Landing AI is a really great one for extracting handwritten text. Let's see. I think, yeah, just to conclude, AI, clearly there's a lot of opportunity. We have found some really valuable use cases for AI, and we're excited to see what else we can come up with as a community. And yeah, but at the same time, we want to make sure that everyone is using it reasonably and responsibly, and we need to come up with really strict or really comprehensive evaluation frameworks for when we are using AI in our work. And yeah, I think feel free to take a look. We have a blog that pretty much outlines what we've just discussed, but we have some other content as well as on our website that we'd be happy to share. And then we have a training as well on AI uses, and especially AI best practices and things to be aware of when you are using AI for such use cases. But at this point, I think we'd love to hear from you all and see if you have any questions or if you want to share any of your own experiences using AI. We'd be happy to hear that. So I'll open it up.
There is one question in the Q&A that I accidentally marked as answered, but I can answer that now. Amalia asks, for the AI-assisted image review, did you not specify hypotheses ahead of time? So we did, not hypotheses exactly. We were using the images to extract some descriptions of the fish ponds. So we gave it a pretty detailed prompt actually, which we tested a couple of times, which one works better and which one doesn't work as well, to say if it's identify the color of the pond, we gave it options, select only from these options, identify if it has grass or vegetation around it, and select from these options. So initially we tried something more open-ended with the prompts, and we realized that it was not consistent in how it responded. And so then in our second or third attempt, we gave it specific questions and said, choose from these options. And if there's any additional notes, you can write them in a notes document. And so we had it output like a JSON format, so it was more structured. And that has been generally a good practice anytime we're trying to extract data from video, image, or text, is to use a JSON format to output the structured information from those images or documents. If Fiona, if you want to answer the second one, where Amalia asks, how did you ensure the proposals were comparable? This is not really an AI question, but if you wanted to say a little bit more about the design itself for the 3IE, for use case 2.
Oh, yeah, so in terms of the evaluation methodology, originally actually we were planning to use a regression discontinuity design because we had scores for the proposals that were accepted versus those that were not. And so we were going to look at just those around the cutoff of that score. However, we quickly realized that that sample was very small and that also, some of the scores varied quite a bit based off of sort of an interview stage that happened later. So we ended up doing more of a difference in difference design where we actually used some of the extracted data from the proposals or from the papers that we wouldn't have had otherwise to sort of match on characteristics that a paper had. And then also did a before and after sort of a difference in difference analysis of the outcomes from the papers. Originally, I think without the AI extraction, we would have only had statistics on whether or not a paper was published, but because we were able to use AI to extract more information from the papers that we did find, because we had done just sort of a web scraping search, once we had the papers, we were able to extract this additional information, which was valuable. I can also answer, I see a question from Tahita on what was the measurement error in the use cases. And actually, probably the one that I can definitely answer it for is use case 1, which was the image classification task. So for the image classification, we actually had 100% accuracy, 0 measurement error for whether or not there was a pond in the image. However, for the other variables, so we did it by variable essentially. And so for the variable of identifying a pond, it was 100% accurate. For the color of the pond, it was all over the place at first because we didn't have we didn't have like categories. Once we set categories of okay, is the pond blue, green, brown, does there appear to be algae, then we increased the accuracy, I want to say over 80%. But yeah, I think it was around 80% for the color of the pond. And then the vegetation surrounding it, we had a similar issue where we realized, we have to like give it categories in order to have a better sense of the actual accuracy. So once we did that, we also had greater than 80 or 90% accuracy on that. And then the software that we used, it was just we used the API for the GPT OpenAI API to classify those images.
There's a question in the Q&A from Joanna. They ask, have you heard of AI-enabled FGD? And if yes, what is your opinion or experience with this? I can take a stab at this. We've come across interviewers, AI interviewers, and AI FGD type tools, we've realized that they can do everything in the interview process, right from helping you come up with the questionnaire, conducting the interview, as well as analyzing the data that's collected from the interview. However, we have been generally cautious about this approach. We would welcome to try it in an application, but there are certain constructs around how interviews should be conducted, and especially with qualitative evaluations, that is kind of holding us back at the moment. But maybe that might change in the future. So yeah, open to experiencing and exploring that option, but we haven't just yet applied it. Yeah.
Geetika, there's one more question I thought you could speak to from Amalia itself, which was that have you run into cases where AI did not pick up on outcomes that humans did? And Amalia says, I get the value of human validation of AI products, but it is one thing to go back to the raw data and check if it existed and generally meant what the AI interpreted, but what about outcome insights that the AI missed completely? And I think in terms of our contribution analysis, we sort of have a plan for this, but in general, if you wanted to answer that.
Sure. Yeah. So one of the use cases that Devika described was looking at decades of documentation and coming up with a structured data set for that, coming up with variables for that, and helping us with the evaluation design itself. So what we realized from that document review was that we would need a mixed methods design, part of which is a contribution analysis. There are several stakeholders and actors in this project that we're undertaking. And in order to capture all of the pathways through which impact might be occurring, we need to gather all of their perspectives. And that needs to happen through interviews and FGDs and surveys that we're conducting at the moment. We do plan to use AI to sort of to analyze that data, but the fact that we are conducting those interviews ourselves and with the support for data collection firm, we are well aware of the hypotheses that we're trying to examine for. And we have a lot of the background from the document review about what the mechanisms are in this project on how impact may occur. That already gives us a little bit of a validation advantage, in the sense that when we see results coming out of the AI analysis, we will be able to flag very carefully whether or not it makes sense. So kind of having a sense making and validation step built into our analysis is key here, and that's what we're trying to implement at the moment.
And I just want to make a technical point here about the difference between looking for outcomes and extracting outcomes. And I think there's different use cases. So some of the examples we showed, we were plainly just extracting outcomes. So it's extremely structured. We're asking it to look into a document and find a specific thing. And that, I think we're less worried about it missing outcome insights because we're predefining exactly what it's supposed to look for. Versus in cases like what Geetika just described, it is looking for outcomes. We're also doing this exercise where we're going to multiple websites and looking for mentions of XYZ topic or something like that, and then getting outcomes from that. And I do think in those cases, there is a risk of missing some outcomes that we would which we may miss anyway, even if we do it the human way. So I think there is that slight risk when we're just looking for outcomes in the wild and we don't know what we're looking for. But I don't think that risk is particularly higher than the one we would have if we were looking as humans as well.
There's another question from Amalia, Fiona, that you could probably speak to, which is how to reconcile confidentiality clauses in assessment contracts with the use of AI.
I actually was going to ask a follow-up on this, so I don't entirely understand. So for what do we mean by confidentiality clauses in the assessment contracts? Like what kinds of assessment contracts? I don't know if Amalia, if you can either speak to that or follow up on the chat. I don't know if
While we wait for that, there was a question about AI ECD from Mohammed. Again, I think we would like to know a little bit more information what you mean by that exactly. If you mean AI capacity building, then yes, 3IE is definitely engaged in AI capacity building. We have developed training modules on how to use AI in different components of evaluation and synthesis and other research tools. And we do provide trainings and capacity building on those topics. And more generally, we have an agenda to continue making progress in that direction. So feel free to email us or write to us if you're interested in that work stream.
there's also a question on which I think could go to any of us, maybe all of us can answer, but what are there any use cases that we're excited to test out next where you think there's a strong potential for the use of AI? And I guess I can start, but I've been so ingrained in this extracting handwritten data and then also the image classification task that for me the most exciting thing has been how can we extract data from images in a way that we hadn't thought of before. I mean, or at least the methods we used to use for extracting image data from images were a lot more complicated to set up. You had to set up like machine learning model with a lot of training data or sort of computer vision models were usually used, but we've been able to do the same sort of tasks with just feeding it through one of the large language models that exists. And so I'm really excited about other use cases related to images, whether that be something like handwritten text or other kinds of images taken on the ground. But yeah, I'll keep thinking about this. I mean, there's a lot of potential, and I think, actually, the other thing is I'm curious to see the applications that come out of this from people on the ground that are working on just solving problems in ways that AI will interact with the practical problems on like in the real world. Right now, a lot of the use cases have been writing code or papers or reports or things that are done on a computer, which I think is still true, but you can use AI to help you build applications that can help you solve problems and, you know, look at images and things that actually exist on the ground. So I think that's exciting. But yeah, feel free to jump in if you had more, Devika or Geetika, or anyone else, honestly, feel free to add to the chat.
Yeah, for me, I think it's still with qualitative analysis, there's been like a sort of skepticism to adopt AI entirely for qualitative coding or thematic coding. What Devika was referring to earlier, giving it predefined codes and having it do the thematic analysis. Uh, like we had said in our presentation, we've tried a couple of software that are designed to do qualitative analysis using AI. The results have been mixed. So there's still scope to see what other innovations happen there, even though, like it was discussed, there's an AI interviewer, an AI FGD, a facilitator, but I'm excited to see what else happens in the qualitative analysis space. Yeah.
Someone just replied talking about the their experience with AI interviewer. They said that they used it end of last year and faced some issues with model hallucinating with probing questions, and took the interview quite off script. And but the platforms improved very quickly, so perhaps this issue has improved since then. But that was their experience last year, which is a great point to share. We were also curious how that tool works.
Amalia has clarified that in the question about how to reconcile confidentiality clauses in assessment contracts with the use of AI. The contracts they were referring to are government contracts that mandate an impact assessment.
Okay, so Are we saying that, sort of, are you basically asking if we can use AI with contracts that have sort of government contracts that have confidentiality clauses? In that case, I mean, I think it depends on the clause. Um, this is something actually we've noticed a lot more in even contracts for work that actually I think just earlier this week we had a new contract come in where we're doing an evaluation currently, or we're about to start an evaluation or a synthesis, and there's a clause at the end of the contract on AI use. And so a lot of we're seeing more and more organizations or funders also including clauses around AI. And so we have to carefully review each of those and think about how can we use AI under this clause? Can we or can we not use it? There's a lot more like legal jargon to go through related to this, and the question of liability if you're using an AI model is also a little bit unclear. Sorry, this might be going off track a little bit. I may still be misunderstanding. However, there's a lot of interesting discussion around um, how can we use AI securely, and I think a lot of it comes back to um, making sure, like treating it the same way as you would as your output. So, like if we're using AI, we need to be ourselves confident in the output and be willing to take ownership of that, and that's often there's always some risk involved in that. And then, yeah, in confidentiality clauses, I mean, my sense is if it's really confidential information, you wouldn't be able to use AI tools unless they have additional privacy considerations. So ALIs is one, and then I think landing AI was another one that I mentioned. Or if you're using like a local LLM and the information does not leave your environment where it's stored, then it's usually safer. But that's typically with any PII. We try to store it in like a non-cloud-based service if possible and try to keep it as secure as possible so that we don't accidentally lose that information or it doesn't go somewhere it wasn't supposed to. So, but again, I might be misunderstanding, but those are some points that are worth discussing.
I would just say +1 to the local LLMs, especially with government contracts or contracts that are really strict. There should be a discussion with the donor, discussing that we will try to set up a local LLM and then use that, or you may not be able to use it. Yeah, I think that's a real risk.
I think
There's a,
related to this.
yeah, go ahead.
Yeah, Nepali just came in with a question about declaring the use of AI in research or evaluation if it's not mentioned in a proposal or contract. And that's, I guess, something we didn't include in our clauses at the end, but typically we do recommend declaring the use of AI depending on to what extent you've used it. I think we're all of the opinion that most people are using AI in their day-to-day work, reading emails, writing, editing your drafts of things. So in general, for little like tasks where you're still reviewing 100% of the output, maybe it's not necessary to declare the use of AI. However, for most of the use cases we mentioned here, we definitely would declare how we used it. In the same way, actually, in those cases, we would declare it in our methods section of a paper or report, the same way we would with any kind of method we used. And then in addition, just for transparency, we like to mention if we used AI for editing, for instance, the blog that this presentation is based off of, we mention at the end that we used AI in some of the editing of the blog. Though that's not necessarily necessary, it might make people feel better about you being transparent.
I would just add that upfront disclosure is something that we've been trying to practice as much as possible in our projects, especially because governments and organizations are still coming up with what their AI policy is or what their stance on the use of AI is. So to avoid any mismatch in expectations in like further down the project, I think we've tried to disclose that we will be using AI for certain tasks and gotten sort of approval and um, uh, people to agree with that stance early on. So that would be the general best practice that we would offer.
Another interesting question we skipped was, do we think traditional data analysis tools such as SPSS will still be relevant for evaluation in the future, considering AI's impact on evaluation? Yeah, I'm curious to hear your guys' thoughts. I think, yeah, go ahead. I can jump in if you have thoughts first.
I was gonna say we've been discussing the different use cases of AI at 3IE, and if you noticed, all of the ones we mentioned have to do mostly with expanding data sources or thinking of X variables and Y variables in different ways and in more imaginative ways. However, I don't think we're at that point yet where it's replacing statistical analysis or even specific qualitative methods of analysis in fundamentally. So these tools are, I think, still useful. Like I personally still use R to write up a simulation of a model, of an econometric model, or just run a regression. Just like, I don't think that those necessarily need to be done away with, because as we know again about this technology, it's mainly predictive technology, it's not deterministic. And so if you are trying to do something precise and mathematical, I would still want have access to something like SPSS or Stata or R to just run the regression myself and see it. But that's just my opinion.
Yeah, almost like a calculator or something where you just I mean your own brain it can be a calculator, but just yeah, verifying the outputs. I think I agree. For discrete tasks especially. But who knows, maybe things will change. And it probably then will transition from what we think of AI right now to some sort of other version of AI that's combining sort of discrete tasks or questions with something more deterministic.
We have two outstanding questions. One from Daniela. Do you need copyrights of images that are fed into AI for analysis?
Typically, yes. I would say that it's the same idea that you have for any use of any images. Like if you are using an image in your blog or you're using it in your report, you're always sort of citing it, if not, if you don't own it. So I think it usually, at least in our field of research, we can get educational licenses or purposes, research licenses for most things, most images that we use. So I would say that yes, and if you don't have a license, make sure that at least you can credit or say that I got this image from this location.
The only thing I would add to that is, again, this question of legality is it's not something I think we can speak to, but a lot of these models are using images to, for instance, if you use a model to create an image, it might be based on images that you don't have copyright to. And that's sort of an area, a gray area, which is a little bit unclear how to cite those images if you create one using one of these models.
And then we have a question from Julie in the chat. Could you speak more on 3I's data innovations group? Is it a community of practice open to all? So it's the data innovations group, which we're all a part of, is an internal working group within 3IE. We are not an external community of practice, but we do welcome any inputs or any ideas that you might have. And we'd be very happy to collaborate as well if there are opportunities. So I'm going to put our email in the chat just so everyone has it. It was up on our slide. But if there are any questions or ideas that you'd like to share with us, please feel free to send them here. Right. We've, I hope we answered everyone's questions. I think we did. Thank you all for engaging with our presentation and for sharing your experiences. This is truly a rich learning experience for us as well. And we hope that you'll reach out and we can stay connected and work on exciting things together in the future. Thank you. Thanks, everyone.